I know I said I was done with the first round of dimensionalism videos, but I completely neglected to incorporate Einsteinian relativity into the theory, so I will do that here. I glossed over it in my mind to go deep into relativity with dimensionalism at first because I had already deduced that gravity was not a fundamental force in part 4. So fully incorporating the theory of general relativity or special relativity didn't seem that important to convey what I had to say at first. But the more I thought about it, it's like, oh, there's like these aspects of relativity are actually very useful in dimensionalism, so I will add that in this part, which will be part 8 in the paper, and what was posted as part 8 will be part 9. Let the viewer know that I am neither a physicist, nor a mathematician, nor a philosopher, but I consider myself fairly well versed and am self-taught in all of these areas, and have made a playlist that incorporates aspects of these fields into what physicists call a grand unified theory of everything. And a grand unified theory of everything seeks to combine quantum mechanics on the micro level and general relativity at the astronomical level into a single working model, because we do not have that single unified theory model at the present day. But I claim that dimensionalism can do just that. But as always, take what I say here with a skeptical grain of salt, and as always, think for yourself. Now what you see behind me is a Penrose diagram, or rather the beginnings of a dimensionalism-minded version of a Penrose diagram. Penrose diagrams have been used by physicists for the past couple of decades to map out the multiverse. Now when we put the 4 dimension types on the 2D grid of the Penrose diagram, we can observe the mass and the electromagnetic phenomena for what they really are. Extra dimensions interacting with space and time. They were already there in the original diagram, but they were not the primary focus. Photons, or light, travels at 45-degree angles in this diagram, because we're assuming that all of space is a vacuum, and because the grid is naturally made to be measured in one length per one time in natural units. I drew an eye in the center to remind that each of us, as individual observers, are at the center of our observable universe. It may sound selfish, but it is a fact of relativity. And here are some interesting ways of using this diagram to show how electromagnetic waves behave with regards to space, time, and mass. Let's say that right now, in a distant part of the universe, that there are alien observers that are similar to us and are just now starting to get their technological repertoire into their space and society. We would not see them and they would not see us until later, because if they are there right now, to us they would be like over here. The light that they would produce, however they choose to communicate, would not be able to reach us until like up here later, and we would not be able to see them until later similarly. Secondly, on this diagram, let's place a huge body of mass that doesn't quite move space-time enough to become a black hole, like a far-off distant galaxy. We'll call that the far-off distant galaxy. They can curve light and make light appear in multiple places at once, and this phenomena is called gravitational lensing. Thirdly, this diagram can help explain why we do not see light from the Big Bang, because if we were able to see light from the Big Bang, we would be ourselves in infinitely distant space. So for us, from our perspective, the earliest light that we can see comes from the cosmic microwave background, which is the electromagnetic singularity of the past. So if we were able to move ourselves at faster than the speed of light to infinitely distant space, we would be able to transport ourselves to this point of reference frame and be able to see the light waves from the Big Bang reach us from that space. So what I'm kind of hitting at is what light experiences from the perspective of a photon. Photons do not experience time the same way we experience time. Like, they can go from one point in space to the other instantaneously from their own perspective. So if we were to travel at the speed of light, our sense of time would be instantaneous. We would not sense time. Time is the thing that changes whenever you travel at faster than the speed of light, not space, because you'll instantaneously be from one point of reference in another point of reference from your own perspective. If you travel 4 light years at the speed of light, you won't experience any time, but everything else will progress by 4 years. Also, the mass of a black hole is so great that the curvature caused by the gravitational lensing makes space become an inevitable end in the future, and at the same time, making time traversable and space-like. And electromagnetic waves really any sort of wave or particle, meet their end at the black hole's center at the mass singularity. So with those ideas in mind, let's go back to Einstein. Throughout his prolific career, Einstein introduced us to many thought experiments that helped expand our understanding of reality. I wanted to revisit the old traveling on a train close to the speed of light with extra observers thought experiment that he performed. So let's do just that. And if you aren't aware of this thought experiment, a layman's version goes something like this. Imagine 2 lightning bolts hitting the ground at the same time, 1 mile or 1 kilometer apart from your own standing bystander's perspective. Now imagine someone else riding a train at 50% the speed of light and are right in the middle between the 2 lightning bolts when they strike. What does this person see? They would see the lightning bolt in front of them strike before they see the lightning bolt behind them. So your objective fact, the lightning bolt struck at the same time, would be wrong from the perspective of someone riding this half light speed train. So let's do another version of this thought experiment. But instead of imagining a train, let's have the vehicle in question be the Starship Enterprise from Star Trek, which can travel at light speed and faster than light. We will ask what would happen in reality to those traveling faster than light relative to other observers, and what would we need to do to make faster than light travel happen in our future reality. For these light speed and faster than light scenarios, we're going to grant the assumption that we have infinite energy supplies and that we wouldn't be crushed by the weight of our own momentum. It is the year 3000 on Earth. You and a friend share the same birthday, born in the same hospital, and just celebrated your mutual 20th birthday party. Your friend got you the gift of an all-expenses-paid trip to a resort on the Proxima Centauri b colony, and you will be traveling to the relatively nearby planet via the USS Enterprise at light speed. You go to Proxima Centauri b for a week and return at light speed. How old are you, and how old is your friend when you return? You are 20 years old. Traveling at light speed, you and all in the USS Enterprise become synonymous with a photon and can travel anywhere in the universe instantaneously, contrary to what the Star Trek universe would have you believe. While you are on Proxima Centauri b, you look up at the sky towards Earth, and the light from the sun are the same collection of photons that hit Earth in the year 3000. But the year is the year 3004 on Proxima Centauri b. Those photons from our sun are 4 years old from their perspective. So you travel back to Earth at light speed, and you find that while you are still 20, your friend is 28 years old and has moved on from your close relationship. The light from Alpha Centauri from the year 3004 is now 4 years old from Earth's perspective in the year AD 3008. So let's do a different scenario. We'll call this scenario B. It is the same scenario as scenario A, but instead of traveling precisely at light speed, you are going to travel 2 times faster than light. How have the perspectives changed for everyone involved? And how old are you and your friend now? You still don't age. You are still 20. But now, when you are on Proxima Centauri b, you look up at the sky towards Earth, and you see the Earth as it was in the year 2998. You are both there and here from your perspective. It is the year 3002 on Proxima Centauri b. When you return to your friend and half expecting to find yourself, you just end up finding that your friend and the Earth have aged 4 years in the year 3004. Similarly, going 4 times faster than light doing the same trip, your friend and the Earth would only age 2 years from your perspective. And going 8 times faster than light, your friend and the Earth would only age 1 year from your perspective. This pattern of factorials would continue on until going infinitely faster than the speed of light, which would result in no lost time between yourself and your friend on Earth. So let's do a different scenario. This time we are going to travel slower than the speed of light. Let's go half the speed of light. How much time do you experience, and what happens there? We'll need to use the Lorentz factor to figure out that one. We'll need to get very specific with the numbers on this one because it matters more here. Now we know that the distance is 4.24 light years. So for you, going half the speed of light without time dilation, it should take you 8.48 years to get from Earth to Proxima Centauri b. And that is what an outside observer who is equidistant between Earth and Proxima Centauri would see. But at half the speed of light, it takes 1.155 seconds for your moving clock to reach 1 second. Thus, you would only experience 7.34 years of flight time on the slow USS Enterprise, just to spend your 1-week vacation on a birthday gift given to you 7.34 years ago. So with that relatively slow time dilation, you would be 34.7 years old whenever you get back to your friend, and your friend would be 36.98 years old, if we take the 1 week's vacation into account. Lastly, for this relativity part, I wanted to go over this question. How could we ever actually achieve faster than light speeds on a spacecraft? And going back to the subtheory of omniversal supersymmetry that I introduced in part 6, I hypothesized that the stuff that would make up negative mass particles should exist. These should be distinct from antiparticles, negative mass antiparticles, and also distinct from the particleless mass of dark matter and the hypothesized particleless negative mass phenomena of negative dark matter. A cohesive negative mass nucleon or atom might be hard to create, however, because the particle would have to incite negative fundamental forces of nature to have a net negative mass. If a spaceship was made with 2 layers of aluminum composite materials and negative mass particles was densely packed between the 2 layers of the whole, the total weight of the ship would go down and make acceleration much easier and requiring less fuel. It is very likely possible that the negative mass and positive mass would annihilate each other if they actually were able to come into contact with each other. But I also hypothesize that they would be hard to bring together because the particles would hypothetically repel each other due to their differing mass type, which is different from the particle-antiparticle annihilation that has the opposing particles attract each other because of their differing charge. Some people say that a perpetual motion machine would be possible from positive and negative mass, but I've personally deduced that this would not be the case, and I'll get into that mental visualization of this deduction in a bit. I have this picture in my mind, and it would be kind of hard for me to draw on the board or on paper, so do your best to follow along, so pay attention. Now the reason this visualization that I have in my mind would be hard to draw is the same reason why in part 6 I made a 4D timeline out of entire instantaneous snippets of 3D space. So I'm going to do my best to describe this picture in words, and hopefully the visualizations in part 6 can start as a good mental foundation to build them. We are going to build a 4-dimensional plane in our minds, so pay attention here. Left to right is space, with right being positive. Up and down is the mass field, with down being positive. To help with the visualization of increased mass creating a greater downward force on a scale, or with gravity creating a greater pull downwards. Forward and back is the electromagnetic field, with more alkaline positive currents being imagined to be closer to you, and acidic negative currents being imagined away from you. And we will imagine time as we normally perceive it, constantly going forward at the rate of normal time, like a movie in our minds. To exercise using this plane in our minds, first let's imagine the entirety of your existence. Let your own personal entirety of life happen before you on this graph. Generally, as you age, your mass will increase. Your aging self will move down on this plane. Maybe you'll lose some weight and move back up, but you'll never reach zero mass like you were before you began to exist. Generally, as you age, your electromagnetic state will be near homeostasis, not too far alkaline and not too far acidic. Human blood tends to be slightly alkaline, however, so your aging self will be slightly closer to you in relation to the 4D point of singularity. For space, as long as we are stuck on Earth, we will be moving across space in a cyclic daily pattern in relation to the Earth's spin, a yearly pattern in relation to the Earth's orbit around the Sun, and once every 230 million years pattern in relation to the Sun's orbit around the center of the galaxy. Relatively speaking, we can never actually be at rest. We can only ever say that our relative position in relation to the Earth has no additional momentum. So your aging self will be zipping to the right on this mental graph very quickly, along with the rest of the Earth, while you as an individual are dipping up and down below the x-axis as you lose and gain particles within your entity. So your aging self will be zipping to the right on this mental graph very quickly, along with the rest of Earth, while you as an individual are dipping up and down below the x-axis as you lose and gain particles with mass within your entity. So now that we've practiced using this mental graph, let's use it to explain Einstein's theory of relativity, to explain gravity and negative mass in a dimensionalism mindset. Let us imagine two equally sized continental-sized asteroids being held in suspension in time, about 5 Earth diameters apart in a vacuum, away from all other forces. These asteroids are pulling down on the fabric of mass-electric space-time the same amount, and are attracted to other bodies of the same positive mass type. We release them from their time constraints to see the causal changes undergo in our minds. As they begin moving towards each other because of gravity, do they stay at the same height of their initial individual masses on the mass dimension, or do they meet at a point that is closer to twice the mass where they began? Indeed, the two asteroids eventually become one body and move downward at a point near twice the mass. And no matter the mass differentiation of the two bodies, they would meet at the center of their combined mass, whatever state would require the least amount of energy for the system to reach equilibrium. Now, what about two bodies of negative mass? What would that do? They would do the exact same thing, except above the x-axis in the mental graph. They would meet at a point double the negative mass at whatever distance allows the system to reach equilibrium with the least amount of energy. If we can imagine the electromagnetic space-time as a nylon fabric, positive mass would be like placing circular marbles on the sheet and letting the fabric bend downward due to actual gravity. And negative mass would be like filling up circular balloons up with helium and releasing them underneath the fabric and letting the fabric be contorted and bent upward by the balloons. So ultimately, back to the mental graph of the vacuum, releasing an asteroid with negative mass underneath this vacuum would cause an asteroid of positive mass to roll away from the source of the negative mass. But if you were to build a spaceship with negative mass being completely surrounded by a material of positive mass, the negative mass here should be at its lowest energy state right smack in the middle of its containment chamber in a vacuum. The biggest caveat to this structure would be to prevent the negative mass being pushed away from the galaxies or the suns or the Earth's gravity once put in there, because I imagine some sort of containment breach or loss of matter is possible if we were to discover negative mass here on Earth, if the entire ship wasn't constantly put within a vacuum chamber. So if the negative mass was in a vacuum chamber between 2 points of mass of the ship, it should be a stable engineering design to build a ship that is capable of light speed. My proposal for testing the creation of negative mass involves freezing neutrinos, or any matter really, to sub-zero Kelvin temperatures. I think scientists should take a closer look at the mass of these sub-zero Kelvin particles and see how they interact with particles of normal temperature. Well, that is all for this video. If you like thinking about this sort of stuff and expanding your logical horizons, please do us a giddy and click on those like and subscribe buttons, and join the group of sea creatures who live in the Notion Ocean. people who are subscribed to Death of a Notion. And until next time, kumbaya, mother duckers.